Hello, math analysis. Here is your key to the Chapter 7 review. So first write the three Pythagorean identities. So starting with, you have cosine squared plus sine squared equals 1. And if we divided everything by cosine, you would end up with 1 plus tangent squared equals secant squared. And if I had taken cosine squared plus sine squared and divided everything by sine squared, I would get cotangent squared plus 1 equals cosecant squared. And then the reciprocal properties for cosecant, the reciprocal of cosecant is 1 over sine, and for secant, it is 1 over cosine. The quotient property, so a quotient is something over something, so tangent is sine over cosine, and the cotangent is the reciprocal of that. Okay, then we get into our identities. Remember, you can only work on one side. So I'm going to work on the left-hand side here, and I'm going to multiply top and bottom by the conjugate of that denominator. And what that does is that is going to give me 1 plus sine on top. On the bottom, I get a difference of squares, 1 minus sine squared, which turns into your Pythagorean identity of cosine squared. And what I can then do is I'm going to bring cosine squared upstairs as secant, because that's its reciprocal. And when I then multiply through, I get secant squared x plus that is rather strange. Well, okay. So it looks like I have secant squared tangent. So it does seem like I'm missing a squared, but I think this turns into 1 over cosine times sine over cosine No, because that's 1 over cosine squared. Sorry, I'm having a moment here. Why is this not working out? I think this was supposed to be a secant squared. I feel like I lost something there. Cosine squared, that's sine squared, so that should probably be a squared there. All right, sorry about that. On the other side, we're just going to distribute. So this is going to distribute to here and to here. So starting off, cosine times secant is 1, because they're reciprocals, plus I have cosine squared y cosecant squared y, and that becomes 1 plus cosine squared y over sine squared y, and that is going to be 1 plus cotangent squared y, which is the cosecant squared y identity. Okay, so now we are getting into evaluating our trig. So arctan of 3, and we want the general solutions. Okay, so remember, arctan only has one general solution. Arctan, so rad 3 over 1, that goes with a 60-degree reference. So this will end up being 60 degrees plus 180 n. And that's your only answer, because 180 degrees later, you'd get the other answer. Now, for our cosine, there are going to be two answers, but the negative says my first answer comes from that second quadrant, because this would be a negative rad 3 over 2. So 1 would be there. So 30-degree reference makes that 150. So I can just say plus or minus 150 plus 360n. And then for cosine, remember you will also get two answers. One will come from the pre-first quadrant, so it's a negative 1/2. So this would be the negative 1, that would be a 2, that would be a rad 3, so it's a 30-degree reference. Realize then your other, where sine is also negative, is over here with a 30-degree. So that would be 210, and this one is negative 30. So I have negative 30 plus 360n, and also then 210 plus 360n. So unfortunately with sine, you can never do just a plus or minus. You want to do the principal quadrant, which is your pre-first quadrant, and then the supplement of that. All right, now down below, where we really get into evaluating. So we look at the inside function first. Remember that the answer to an inverse, so if I have an inverse trig, what goes here is a ratio, and the answer is an angle measure. But if I just have trig, it's the trig of an angle, and the answer is a ratio. So here, inverse sine negative 1/2 is standing in for my theta. So what angle goes with that? Well, we just did that one. That would be a negative 30 degrees. And tangent of negative 30, if you're not sure, you can draw the triangle. That would be a negative 1, 2, rad 3. So then the answer would be negative 1 over rad 3, opposite over adjacent for tangent. All right, so over here we have secant and cosine. So this is now standing in for theta. So what we're going to do, since it's negative, we draw the triangle because it's not something you can figure out. So negative 3, 5, that would be 4. So the secant of that angle is going to be the hypotenuse over the opposite, so negative 5/3. And over here, we have sine of 3 pi over 4. So evaluating that, sine of 3 pi over 4 is over here. So 1, negative 1, rad 2. So it's a positive. And the inverse of sine, since that's a positive, comes from the first quadrant. And I should do it in, whoops, I chose the wrong thing. Sorry about that, wanted the eraser. So this will be pi over 4. And then lastly, we have inverse cosine, so that's going to stand in for theta. So inverse cosine of negative, cosine's negative over here, so negative rad 3, 2. So it's a 30-degree reference, so that's 150 degrees, or 5 pi over 6. And cosine of 5 pi over 6 is also going to be a negative rad 3 over 2. All right? And we keep going. Get some more practice with these. All right, so inverse cosine, this is standing in for theta. So the inverse cosine of 1/2 is a 60-degree, or pi over 3, and sine of pi over 3 is rad 3 over 2. here the inverse tangent, so that's standing in for theta. So if you're not sure, we can draw the triangle. Opposite over adjacent is going to be a 30-degree angle, and the cosine of 30 degrees, pi over 6, is rad 3 over 2 as well. And now down here, we have to set up the triangle. So tangent 5 opposite over hypotenuse, that makes the adjacent 12. Here's my theta, so the tangent of that is the opposite over the adjacent. And lastly, since this is in the first quadrant, these two can just cancel, and it'll be 5 pi over 6. All right, last two problems here are the solving. So we want to isolate our tangent first, so we're going to divide by 3. Realize that this is the rationalized version of 1 over rad 3. So I have, after I do that, I'm going to do an inverse tan of both sides. So that equals the inverse tan of 1 over rad 3. So that's going to be opposite, so that's a 30-degree angle. So I can say 30 degrees plus 180n, and that is theta minus 40, so I still have to add 40 to both sides. And that's then going to give me a general solution of 70 degrees plus 180n. So I know that theta will be 70. If I add 180 to that, I'm at 250. And I'm still, but if I add another 80, I will be outside the domain. So that's a tan, where you just have the one answer plus 180n, because it has a period of 180. And then to do the sine, we also start off by isolating your trig. So again, remember that that's your 1 over rad 2, or 45 degrees. So I'm going to take the inverse sine of both sides. So the inverse sine, rad 2 over 2. Since it's positive, that's going to be 45 degrees, and also 135, because sine is positive in the first and the second quadrant, but those are both theta minus 30, so I have to add 30 to these. So that one gets 30, that one gets 30. So that my general solution is going to be 75 plus 360n and 165 plus 360n. And because you're adding 360, basically your particular is just going to be these two values. All right? So I hope that helped. With sine, you always have to get the one value and the supplement, because sine is positive in 2 quadrants. With cosine, you can always throw a plus or minus on your general, because that'll give you the 2 quadrants where it's positive or negative. Tangent, it's always just one answer plus 180n. I forgot my n there. All right, I hope this helped.